Hello everyone, this is Ilavarasi, Assistant Professor, Department of EEE, Karpagam Academy of Higher Education. Hope you remember our previous 3 modules which we have discussed about the electrical parameters. In that we have come across the voltage, current, power and everything. And then in our second module we have discussed about the Ohm's law. We know that voltage is directly proportional to current provided your temperature remains constant, and we have discussed a few problems on that. In the third module also we have come across the factors that the resistance of a conductor depends. In that I have told you about the resistivity, length and about the area of the conductor, and problems has been solved on that module. And in today's module we are going to discuss about the resistors in series. So we all know this is the symbol of a resistor. And this is the supply. And always a current will pass through the circuit, and this is the resistive element R1 and R2 and R3. A resistor is an element that which opposes or restricts the flow of your electric current, and resistance is provided in this resistor, and these resistors are specially designed for producing the resistance. And here V is your supply voltage. And I is nothing but the circuit current. R1, R2 and R3 are your resistors. And current is passing through it and voltage is also passing through it. And across each resistor element there will be a voltage drop which we can name as V1, V2 and V3. And this V1, V2 and V3 are voltage drops. So we know that in the module I have taught you about Ohm's law. So by Ohm's law we need to remember voltage V will be equal to I into R. And then the second thing, by KVL, Kirchhoff's voltage law, the sum of voltages will be equal to the voltage produced will be equal to voltage drop across each resistors. So the total voltage developed will be equal to V1 plus V2 plus V3. So this is also you need to remember. So this is your first one. So we all know that V is equal to I into R. So that V1 will be written as I into R1. Because across V1 we have R1 resistor and current passing through the element will be always same. So V1 is equal to I into R1 and V2 will be equal to I into R2 and V3 will be equal to I into R3. So combining this we will get I into R will be equal to I into R1 plus I into R2 plus I into R3. So I am taking this current value as common outside. So what happens? IR will be equal to I into R1 plus R2 plus R3. So both the values are same. So strike it out. So the value of resistor R will be equal to R1 plus R2 plus R3. So I am saying when two resistors are connected end to end, two or more than two resistors, when they are connected end to end, that is what we call it as series connection. So in series connection, the final thing will be R total resistance will be equal to R1 plus R2 plus R3. Three main points we need to remember in case of your series circuit. The first thing is current passing through the resistor will be same. Same current will flow through the entire circuit. And the next thing is the voltage drops across each element will be different. Voltage drop will be different. This is based on your Kirchhoff's voltage law. And the third one is the voltage drop will be the summation of the applied voltage. So these are the three things you need to remember in case of your series circuit. So moving to the problem. Here we have a resistor R1. So a resistor R1 of ohmic value 30 ohms is connected across a unknown resistor. Unknown resistor value is R2. So this is R1 and the value of R1 is 30 ohms. And it has been connected in series with the R2 resistance. I don't know the value of R2. So this is what the value I need to find out. Okay. And current that is passing through the circuit. Current of 2 amps is passing through the circuit. Here we have two voltage drops. Your V1 value is 144 volts and your V2 value is 96 volts. So here we have 144 and 96. So now let's move to problems on series circuits. We have a resistor of ohmic value. Ohmic value is 30 ohms. It is connected in series with a unknown resistor. The voltage drop that is developed across the circuit is 144 volts and 96 volts. So we need to find the value of current and also the unknown resistor value. So based on this problem we can able to construct a circuit, right? So we have two resistors R1 and R2, two resistors. R1 value is 30 ohms whereas R2 value is unknown. And I am giving a supply here. And I am saying across the resistor R1 there will be a voltage drop V1 and that voltage drop is nothing but 144 volts. And across R2 there will be a voltage drop V2 and that is 96 volts. So we know that Ohm's law is nothing but V is equal to I into R. So now I have V1 and I have R1 value. So V1 is nothing but 144 volts. And I is the unknown term and R1 is nothing but 30. So from this I can get I will be equal to 4.8 amps. Bringing the 30 to the division I will get my current value is 4.8 amps. Now remember the next unknown value is nothing but R2. So coming to R2 we know that V2 will be equal to I into R2. So V2 is 96 and I have calculated as 4.8. And R is unknown. So what happens? My R2 will be equal to 20 ohms. So the two unknown values are find out, I and R2. So this is how a series circuit has to be solved. And moving to the next problem. We have 3 resistors in a circuit, and 3 resistors are RA, RB and RC, and we have voltage drop across 3 resistors. And the voltage drop will be VA, VB and VC. We have a total voltage applied across it, and that total applied voltage is 250 volts, and current that is passing through the circuit is 2 amps. And in this voltage drop, VA value is unknown and VB value is 80 volts and VC value is also unknown one. So based on this, I am going to construct a circuit. The first thing is I have 3 resistors, R1, R2 and R3. So this has been connected to a supply, and this supply value is 250 volts. So positive, negative. A current that is passing through the circuit is 2 amps. And this is my resistor RA, and this is my resistor RB, and this is my resistor RC. And my resistance RC value is 50 ohms. And as I told you, I have a voltage drop of VB across it, and this is 80 volts. So here we need to find the value of VA, and here it is VC. You all remember that by Ohm's law, what happens? My VC will be equal to I into RC. So we know that the value of current passing through a circuit, series circuit, will be always same. I is equal to 2 amps will flow through your resistance RA, RB and RC. So what happens? 2 into your RC ohmic resistance value is 50. So my VC will be equal to 100 volts. So I have calculated the value of VC. Now the second main rule in your series circuit is nothing but, according to your Kirchhoff's voltage law, the voltage developed in a circuit will be equal to the voltage drop across all the circuits, right? So what happens? Voltage developed V will be equal to VA plus VB plus VC. So I know my voltage developed will be 250. That has been given in the problem as 250. And VA is the value that is unknown. And VB is the value that has been given in the problem as 80. And VC I have calculated as 100. So what happens? VA plus 180. So my VA value will be equal to 70 volts. Finally, I have calculated all my VA, VB and VC values. What is the value of VA? 70. What is the value of VC? That is 100 volts. Now what is the remaining parameter that I need to find out? I need to find out the value of RA and RB. So what is the formula for calculating RA and RB? We all know that my VA will be equal to I into RA. So I know the value of VA. VA is nothing but 70, and I know the value of current 2, and RA is unknown. So RA will be 35 ohms. So the next thing is I need to find the value of RB. So this is also written by VB is equal to I into RB. So VB is the value of 80 and current is the value of 2, and RB I need to find out. So RB will be equal to 40 ohms. So finally VA, VB, VC done, RA, RB, RC done. This is how we need to calculate the values in a series circuit. So in the upcoming module we will discuss about the parallel circuit. Thank you.